Akka 3 is very interesting in that it has what I kind of think of as a recursive architecture. And what I mean by that is that it's recursive in event-driven architecture. Being recursive, it's not only event-driven on the outside, which is very typical of event-driven applications where you have microservices that are communicating in some form of event-driven way, but even more interesting, I think, is that these microservices are event-driven on the inside, and that's what I want to show you in this video. So why is this important, though? Because I think it's because that we build our system. We want them to be scalable and performant, and we don't want them to break. We don't want them to disappoint our users or upset our business sponsors, those types of things. And of course, we want them to be loosely coupled and modular, so it makes it easier to build and maintain and run these things. What I want to do, though, is let's start with the outside, the more traditional type of environment. So here I just have a diagram where I'm showing, say, a simple microservice application where there's 6 microservices. But here, the communication between the microservices is done via an event-driven type of approach, where the messaging is async pub sub. So as an example, you have microservice A that's doing its work and is producing events, and some of those events are of interest to microservice B. Microservice B gets triggered by some of those events from A. It does some work. It produces its own events, which are of interest to microservice C. So the flow continues. So microservice C gets triggered by B. It does some work, produces some events that's interesting to other services, and it's also interesting to microservice B. So there's kind of a backward flow of communication, and just continuing on with that. C, it triggers B, B triggers A, and we have this kind of flow going on where there's all these messages occurring between different microservices are done through async pub sub. So in effect, we've got these event streams that are flowing. A really cool feature of the Akka 3 platform is that to make all this work is built in. There's a brokerless pub sub feature of the platform, so there's no excuse not to do it this way. I think it's so easy to do, and that's just the start of it. There's the components and the way you build microservices that we'll see in a minute make that easier. So that's what we're going to do. We're going to kind of go from the outside perspective and zoom into the inside. So on the inside, you build Akka 3 microservices using components, and there's 6 different types of components. In this video, I'm going to show you 3 of the 6 components. But first, what I want to show, though, is that one way that these components can communicate with each other is using an event-driven type of approach. So one component can emit events that are of interest to another component, and that component can emit events that are interested in another component. You can have these all these different flows that are occurring within components. A more specific example, though, is say we have one of the components is a shopping cart, and it's built as a specific type of component, which is a entity, and there's an event source entity type as well. So it's very easy to build event sourcing types of entity components. So the shopping cart is producing events. Some of those events are of interest to other components, like this order event source entity. So when in particular, when a shopping cart does a checkout, we want to get an order created so we can process that order. And then the flow continues. The order can produce events that are of interest to other entities. And also, here's a third component, or a second component, that are views. These are queryable components. Where, they create tables, basically, that you can perform queries. So this is CQRS. Commands, which are requests to perform some kind of state-changing operation, or go to the entities. Queries go to the views. But views are consumers of the events from the command processors, the entities that are processing commands. So that's a very common pattern here. So now, taking a look at it from both the outside and the inside, from an Akka 3 perspective, you've got components in one service. Like in this one case, there's one component that's producing events that are of interest to components in another service. And setting that up to do that form of communication, where in this diagram I'm showing that it's not only the service on the left is producing the events that are of interest to the service on the right, the service on the right is producing events that are interests of service on the left. This is very easy to set up. By the way, all the messaging that's occurring here is it guaranteed at least once delivery. So these messages will get delivered eventually. At some point, they will get delivered, guaranteed. That's built into the behavior of the way the platform works. I want to show you some code, though, that does this in a more specific way. So the code I want to show you is I've got two services I've implemented. One has a shopping cart entity and an order entity and an order view. And what's happening when the shopping cart produces a checkout event, that's going to get triggered the creation of an order in its own microservice. But it's also that checkout event is going to trigger the creation of another kind of order in another service. So let's take a look at the code. So here's a shopping cart. It gets the checkout command. That checkout command gets processed. What happens is commands get processed and they produce none, one, or more events. So in this case, we have a command that's producing maybe an event that gets persisted. Then what happens is when those events are getting persisted, they're getting picked up by a third component type here, which is called the consumer. So you can see the consumer has an annotation that says consume from an event source entity, and you call out the specific entity that you want to consume from, which is the shopping cart entity. So Akka 3 is handling all the plumbing of this, but basically what's happening as quickly as possible as events are getting created by the producer, which is the entity, they're getting passed to and processed by the consumer, which is here in this consumer component. So you can see I have a method that just picks up all the different events, but is filtering on just the checkout event. So when we get a checkout event, what we're doing is we're basically just building a command, a create order command, and we're calling then, this is it's called a component client. We're calling this other component, this other event source entity component for the order, processing orders, and we're passing it a create order command. There's another component or consumer component here that this is the one that's also consuming from the shopping cart entity, but it's got another annotation. You can see it's called a producer, and it's producing a service stream, or I like to think of it as an event stream. And here it's almost the same in that Akka 3 is picking up those events, passing it to our consumer component. I wrote the code here to filter on just the checkout event. That's the only one I'm interested in. I wrote this little method to handle that event. But now instead of calling another component, I'm just doing a produce. So it's just publishing basically externally from this service is publishing this checkout event. In another project, I've got a consumer on the other side. You can see that it's consuming. This annotation is a little bit more involved than in that you have to specify what service you want to consume from, what event stream you want to consume from, and but then once you've got that, the processing is pretty much identical. We have a method for getting the events passed to it. I'm filtering on just the checkout event and building a command to create an order in this second service and calling that component, because this is event-driven processing being handled within this single service. Just to show you another example, here's a view in this second service, which it has this query, and that's what the view is for, but it also has an internal consumer. So you can see that we got that consumer annotation from event source entity. In this case, we're consuming from the order entity, and we're projecting that into the view, which is basically a table. So what I want to do is run a quick demo where I'm going to run these two services locally and just create a shopping cart and then check it out and then watch how the data flows between these two. So if I go back to the first service, I'm going to go to the shopping cart, and you can see this is running on port 9001. And I got all these predefined HTTP methods, so I'm going to do add an item to the cart, and then I'm just going to do a checkout. And then now the shopping cart should be checked out. And if I go to the other project, I've got processing here, and if everything worked well, the data should be in the view. So if I go and, there it is. So I did a query on the view in the second service, so that order has been created, and then that event was picked up are picked up and then projected into the view in the second service. So this was an example running things locally, but I want to add a little bit more to this diagram to show you not only the components for the entities and views, but the third component, the consumers. So you can see there was a consumer that was picking up events coming from the shopping cart entity and building commands and sending it to an order entity. But there was another consumer that was picking up events and producing them so that they're externally available. And there's the other service that was interested in consuming from the service on the left. The service on the right had another consumer that was picking up those events on its edge and then building a command and creating, sending that command to its own, the second service's order entity. And we also looked at the consumer that was picking up those events from this entity and projecting them off to a view. So these are 3 of the 6 components. These are like Lego blocks in a way that there's these 6 fundamental components for building services using Akka 3, and it's very powerful. So want to go more into the why on this. The whole reason for having microservices, not the whole reason, but one of the big reasons is that you can deploy individual microservices and run them. And the traditional way is if you need to scale a microservice, you can run multiple microservices. And these microservices run independently from each other, and they run on some kind of distributed infrastructure. One of the most common ones, of course, is a Kubernetes cluster. But what I think is really cool is that with an Akka 3 microservice, internally on the inside, it does the same thing because the components themselves talk to each other, communicate with each other through messaging, through guaranteed messaging. And this allows microservices, these Akka 3 microservices, to scale across a distributed infrastructure like a Kubernetes cluster. This is where the real power comes in. You don't have to run multiple instances of your microservices and manually scale, or to maybe manually or automatically scale up or scale down your service. It's in the Akka system is organic. The system scales up as it needs more with the assistance of things like Kubernetes, and the workload gets distributed across a distributed infrastructure. So this is where things are a little bit different in that with traditional microservices, the level of elasticity is, as I'm kind of calling it, coarse-grained. You run multiple instances of your microservices to give you that scale. Whereas with the Akka 3 microservices, it's a more fine-grained elasticity. The microservice itself can scale across a distributed cluster. And just as a teaser, another feature, and doesn't require any code changes to do this, is what I'm calling geographic elasticity or multi-region, where you can deploy a single microservice and it gets it's run in multiple regions, multiple geographic regions, and even on different clouds. So one part of the microservice could be running on Amazon, another part of the microservice could be running on Google. It doesn't matter. No code changes, nothing. Data gets replicated by Akka. Everything's there, and so it's another level of scale. So this is where I think event-driven, this is why I'm a huge fan of event-driven, is that it's ideal for distributed processing and distributed processing done right. And it's this really cool feature of this recursive architecture where we have event-driven on the outside, but even more interesting, I think, is the event-driven on the inside. So I hope this was of interest to you. Certainly, you can take a look at more details on how this is done and how Akka works itself. Go to the akka.io site, go to the documentation at doc.akka.io. Please like and subscribe. Keep learning, and we'll see you in the next one.